Hello, thank you for joining me once again as we still exploit some concepts in trigonometry. This afternoon we are going to cover the topic with the heading the form a cos theta plus b sin theta. That is just a basic concept, but it can be interchanged as you see in the other examples that you'll try out. So we are going to solve the equations down there for values of theta in between 0 degrees and 360 inclusive, and that is our first equation. As you might observe, there are very many methods that we have studied, not really many, but this time around we are going to use the form that I've explained above. Now what is going to happen? We are going to look for a value that when we divide it through the equation above there, it will give us the form of the equation in blue down here. Now how do we get that value? We get that value by comparing the equation that we have written, that one and that second one. We compare them and then get that value of which we are going to divide through in the first expression or the equation that we are solving, such that it maintains the form of this other one. As you can see, I've written the second one or the one in the equation such that it can be easily comparable with that, and once you compare, you will observe that when you compare the cos theta cos alpha with cos theta times root 3, cos theta crosses out and you remain with cos alpha is equal to root 3. Likewise to sin alpha, whereby sin theta and sin theta cancel out, you remain with sin alpha is equal to 1. You'll observe that tan alpha, which is sine over cos, is equal to 1 over root 3. And therefore we have obtained the value of alpha, which is equal to the arctan of 1 over root 3. When you press that on your calculator, you're going to get the value of alpha as 30 degrees. So we have gotten the value of alpha that we are going to replace right there. And so we go back to our basic diagram of obtaining that particular value that we want. And so you'll observe that sin alpha is equal to 1. So when I put the alpha down there, it means the opposite is 1. And then the cos alpha is also root 3. I cannot guarantee that the hypotenuse is 1. How? Because that is the value that I'm looking for, such that I divide it throughout my equation in the question. So I'll use Pythagoras theorem to obtain the hypotenuse, and I'll obtain my hypotenuse as 2. Now 2 is the value that I'm going to divide throughout the equation in the question. Hope we are moving together. Do not get lost. I hope you are writing somewhere and following critically step by step. It will help you. So I divide each part of that equation by 2, and after dividing by 2, I would have written it in the format before that I have shown you already. Meaning that when you divide by 2, we can equate it to the equation that we thought about that could be written in that form, which is cos theta minus alpha. However, our alpha, if you remember, is 30 degrees. Meaning cos theta minus 30 is equal to a half. Why? Because in the equation it already told us that it is equal to 1, and we divided by 2 to get that a half. And therefore we can get the other values of theta using that expression, getting the arc cos of a half there to find theta minus 30 degrees. It will give us 60 degrees. And so we shall write the general formula for cos theta, which we already know, which is 360 n plus or minus theta. And therefore when we want to find the other angles of theta minus 30 degrees using the principal value of 60 degrees, we shall put it in our equation down there, and when n is 0, theta minus 30 is going to be equal to negative 60 and positive 60. When n is equal to 1, theta minus 30 degrees is going to be equal to 360 minus 60, which is 300 degrees, and 360 plus 60, which is 420 degrees. And so when n is equals to 2, it gives us theta minus 30, which is outside range, leaving us with the values of theta minus 30 degrees as 60 degrees, 300 degrees only, because 420 degrees is also outside range. So theta only, we add 30 to those two angles, we shall obtain 90 degrees and 330 degrees. Thank you.